In this lesson, we're going to be taking a look at finding cube roots. It's just the logical continuation of our last lesson on square roots. So your goal is to understand the concept of cube roots and to also understand other roots. Now, just so you know, your classwork and homework will not be about other roots beyond cube roots, but it's a good place to talk about it just so that in the future you know what it's all about. So let's take a look at this geometry problem. How would you find the volume of this cube? Now, hopefully you remember from a previous class that to find the volume of a cube, all we have to do is find the area of the base, which is 3 times 3, and multiply that area by the height, which is also 3. So in other words, our problem is 3 times 3 times 3, or 3 to the third, or 3 cubed. So just like we call something to the second power squared, this is why we call something cubed, because we're literally finding the volume of a cube. Now 3 to the third power, or 3 times 3 times 3, is 27. So this problem would have an answer of 27 cubic inches. So now what we want to discuss is, what if it was a similar problem? What if we had this? How would you find the side length of this cube knowing that the volume inside is 64 cubic feet? Well, we just want to take the opposite of what we were doing here. In other words, what times what times what would be 64. Okay, so in this case we have some unknown. Now in this case though, also we're talking about a cube, so whatever the side lengths are on all three sides, they're all the same, so let's call them n. So really this problem becomes n times n times n equals 64, or n cubed is 64. So what we want to do is we want to reverse the process. Like most things in math, everything has its opposites. Multiplication has division, addition has subtraction. For powers or exponents, we have roots. So just like with square roots, we have cube roots. And for this, we use the same radical symbol, except if I just use this symbol, we think this is square root. So to show that this is actually a cube root, right here in this little divot, you'll see a 3. This means we're looking for the cubed root. Now, what I do to one side, I do to the other. So just like with squares and square roots, cubes and cube roots cancel each other out. We get n. And then I just have to think to myself, what times what times what is 64, just like we were talking about here. And in this case, it turns out that it's 4. So this is a 4 foot by 4 foot by 4 foot cube. And this is the concept of cubed roots. Okay. So what we've learned is that, just like with a lot of other things in math, exponents have their opposites. That in this case, x to the power of n and x to the nth root x are inverse operations. In other words, for our example here, our two opposites were x to the third, and over here, the cubed root of x. So basically, that's how we do anything beyond the power of 2. Now, we're not going to do it in our work like we talked about, but if I gave you something like n to the 5th power, the opposite of that would be to take the 5th root of n. And so to denote that, we use our radical symbol with the little 5 here in the corner. And it goes on forever. If I wanted to do n to the power of 10, but later in the problem I needed to undo that move, I would do the 10th root of n. Okay, so let's move on. So let's try out these problems. The third root of 8, or the cubed root of 8. What times what times what would be 8. Here we've got the cubed root of 64 and the cubed root of negative 27, which at first glance might be like, what's going on there? But we'll talk about that. So think about this and see if you can complete these first. Take a moment, maybe pause the video. Alright, so hopefully you figured out that for 8, it's 2 times 2 times 2, so the cubed root of 8 is 2. Now, just like with square roots, since there's no negative sign or positive and negative, they only want the positive cubed root, so we're just going to put 2. On this next one, we actually had this in the last example, it was 4. 4 times 4 is 16. 16 times 4 is 64. Now, here, You might be thinking, well, didn't we just learn in the last unit that you cannot square root negatives? But here, we've got the cube root of a negative. Now, at first glance, we might think, well, if it doesn't work for square roots, it shouldn't work for cube roots. But actually, it does. We do have an answer here of -3. And the reason why we can cube root negatives but we can't square root them is because think about the nature of multiplication in negatives. The way we got -27 was to do -3 times -3 times -3. And so what happens here is -3 times -3 is +9, but then 9 positive times another -3 changes it back to a negative. Oops, that's an ugly 7. So in fact, it is possible to cube root negatives, although we can't square root negatives. All right, one last thing to discuss. What about large numbers? Well, the only thing I'm going to say here is go back to our two strategies. One strategy is to prime factorize. I can take 216, I can start breaking it down to its prime factors. In this case, 2 times 108, 2 times 54. Let's see, that's going to be 2 times 27. 27 is 3 times 9. And 9 is 3 times 3. Okay, but in this case, we are taking the cube root, not the square root. So the only thing that changes in our strategy here is to take the numbers. In this case, 2 times 2 times 2 times 3 times 3 times 3. And then, instead of putting them into two different groups, because we're taking the cube root, we're going to reorganize these into three groups. Basically 2 times 3 times 2 times 3 times 2 times 3. Oops, went a little too far. Which really equates to, if I put parentheses, 6 times 6 times 6. So the cubed root of 216 is 6. Okay, now let's say you don't want to go through all this. Once again, our other strategy from square roots is to just use some educated guessing, some targeted estimation. So basically what I like to do is I like to try out some numbers that are fairly easy to work with. So what I'll do is I'll take maybe 5 cubed. And let's assume I didn't know what the answer was already. 5 times 5 is 25. 25 times 5 is 125. A little bit too small. So maybe I move my targeted guess up a little bit higher. Maybe 7. So it turns out 7 times 7 is 49. And 49 times 7 turns out to be 343. And little by little, I just use some targeted guessing and then narrow my answers down. And we find out eventually it's right in between. 6 to the third. 6 times 6 is 36, and 36 times 6 is 216. So don't forget about these two strategies from square roots because they're going to help us out with cube roots. Okay, so take this information and use it to complete your classwork, and good luck.